an alarming trend in the Gulf right now.
The Gulf of Mexico specifically is warming twice as fast as the rest of the oceans.
Beneath the calm, turquoise waters of the Gulf of Mexico, something strange is happening. It's not an oil spill. It's not a hurricane. It's not even a shipwreck. It's something far older, far deeper, and far more mysterious. For decades, the Gulf has been viewed as a relatively stable geological zone, home to massive oil fields, coral reefs, and warm ocean currents. But recent discoveries are turning that perception upside down. In the last few months,
that is not rain. That is not how weather works. There are weird waves showing up on the radar. So again, we'll start with that's rain.
The rain.
Goodbye to the rain.
And that.
Scientists studying satellite data, seafloor scans, and seismic records have detected an unusual, persistent bulge rising from the ocean floor. One that defies easy explanation. This isn't a rogue wave or a shifting sandbar. It's something geological, something alive, the kind of anomaly that has researchers whispering about hidden faults, underwater volcanoes, and worst of all, an awakening deep beneath the crust. What is it? Could the Gulf of Mexico be harboring a rising volcanic system long overlooked? And if so, what could it mean for the millions of people living along the U.S. Gulf Coast? Let's dive deep into the waters and deeper into the mystery. Seafloor uplift, a silent surge. What if the very floor of the Gulf of Mexico is rising right beneath our feet? What if the calm waters we trust conceal an ancient force slowly stretching the Earth's skin? And why now? In a region long believed to be geologically quiet, is something starting to shift? The first hints of an unfolding mystery emerged not from research labs, but from offshore oil and gas operations. Commercial sonar scans, typically used for resource exploration, began to detect subtle but consistent changes in seafloor elevation. For decades, the bathymetry of this stretch of the Gulf had remained virtually static. Then, without warning, it began to lift. A broad dome, nearly 50 kilometers, 30 miles wide, appeared to be swelling upward at an imperceptible but steady rate, about 2 to 3.4 centimeters per year. That might sound minuscule to the untrained eye, but for geologists, this was a glaring red flag. Vertical motion of this magnitude, sustained over months and years, often precedes major geodynamic shifts. Marine geophysicists initially approached the data with skepticism. After all, sonar readings can be distorted by temperature, salinity, or even equipment drift. But when high-resolution satellite altimetry confirmed the bulge, independently observed through minute changes in ocean surface height, it became clear this was no fluke. Tide gauge stations from Louisiana to Mississippi added further confirmation. The Gulf was pushing upward from below. Geographically, the swelling zone lies approximately 200 kilometers south of New Orleans, near the Sigsbee Escarpment, a dramatic underwater cliff formed by ancient salt tectonics. This area has long been overlooked in terms of volcanic potential, but that's precisely what makes it so unnerving. It lies at the intersection of salt domes, deep faults, and rift-like crustal weaknesses that could, under the right thermal pressure, act as conduits for magma. The dome's asymmetry, rising faster in the northeast quadrant, has scientists theorizing that magma may be moving laterally through fractured pathways, seeking the path of least resistance. And all this is happening just beneath one of the busiest shipping and energy corridors in the Western Hemisphere. This was no longer just an anomaly. It was a geologic event in motion. And the deeper scientists dug, figuratively and literally, the more they began to suspect that something ancient was reawakening beneath the Gulf of Mexico. The pattern was real. A gentle dome-shaped bulge is slowly lifting part of the Gulf's floor, centered roughly 200 kilometers south of Louisiana. And it's not caused by sediment buildup or glacial rebound. beneath this swelling dome lies something else: anomalous heat. What makes this uplift especially concerning is its consistency and scale. Over the last 18 months, satellite radar data, particularly from the Sentinel-1 and TerraSAR-X missions, have documented steady vertical movement of up to 3.4 centimeters per year. While that number may seem small, in geological terms, it represents significant energy building beneath the crust. Additionally, the uplift pattern is not perfectly symmetrical. Instead, it shows a lopsided swelling, with the northeastern quadrant rising slightly faster than other sectors. This kind of deformation can signal an uneven or migrating source of pressure below, possibly a growing magmatic intrusion navigating through older fault zones. Geologists also note the absence of any significant sedimentary shifts that would normally accompany subsurface oil or gas accumulation. The Gulf is rich in hydrocarbons, but these processes tend to create downward compaction rather than uplift. The current dome contradicts that trend, pointing to a deeper, hotter, and more dynamic force at play. This is why scientists are urgently deploying more geodetic instruments, like bottom pressure recorders and tilt meters, to track every millimeter of motion. They're creating detailed subsurface models to better understand the mechanics behind the dome. So far, those models suggest the possibility of a slowly inflating magma chamber, something never before confirmed in this region. Such a development would represent a seismic shift in our understanding of Gulf geology, and it raises an urgent question: is the seafloor preparing to rupture? Subsurface heat, a rising pulse. What if the warmth we associate with the Gulf of Mexico is no longer just a surface phenomenon? What if deep beneath its seabed, a fire is slowly waking up, one that hasn't burned in thousands or even millions of years? Thermal imaging, conducted by remotely operated submersibles, ROVs, has revealed a disturbing trend: clusters of hotspots, zones where the ocean floor emits significantly more heat than expected. These aren't your typical hydrothermal vents that form along known mid-ocean ridges. These are diffuse, irregular, and strangely aligned with the swelling dome identified just south of Louisiana. In some cases, seafloor temperatures measured nearly 20 degrees Celsius, higher than the expected baseline at comparable depths, enough to raise concerns among the U.S. Geological Survey. The team noted that these anomalies are not just scattered randomly. Instead, they form a crescent pattern tracing the eastern and southeastern flanks of the dome, suggesting the possible edges of an underlying magmatic intrusion. Let that sink in. A rising heat field, seafloor temperatures spiking, and something glowing faintly beneath the sediment, detectable only through the lens of infrared imaging and deep electromagnetic surveys. Core drilling in the area brought up even more disturbing clues. Rocks taken from over 300 meters beneath the seafloor showed unmistakable signs of hydrothermal alteration. These included layers of smectite transformed into elite, something that only happens after prolonged exposure to temperatures exceeding 200 degrees Celsius. The presence of pyrite and silica veining, often seen in ancient volcanic settings, suggests superheated fluids have been circulating through this crust for years, maybe decades. And then there's the gas, pockets of trapped carbon dioxide and trace hydrogen sulfide, both common in magmatic systems. Some vents even released helium isotopes consistent with a mantle source, something typically found only in volcanically active regions like Iceland or Kamchatka. One of the most unsettling findings came from a magnetotelluric survey conducted over the dome. The data revealed a wide low-resistivity zone beginning about 4 kilometers beneath the seafloor. Such anomalies are often linked to molten or partially molten rock, indicating that we might not just be looking at a zone of heat, but an actual magma reservoir quietly forming or expanding. This isn't just a quirk of geology. It's a sign of life beneath the crust, geological life, and it's rising. The The Gulf's story is no longer just about oil and hurricanes. It may soon include magma, pressure, and the possibility of an awakening. Gas seeps and mud volcanoes. Warnings from below. What if the ocean itself is exhaling, quietly, but with increasing urgency? What if the whispers of gas and mud escaping from the seafloor are more than just geological quirks? What if they're the first signs of something ancient stirring beneath the crust? As researchers probed deeper into the mysterious dome region, they began to notice something eerie. Ghostly plumes rising steadily through the water column, captured by sonar in luminous, shimmering columns. Some were calm spirals of methane, others were violent, hissing expulsions of superheated mud and gas, erupting from gnarled cracks in the seabed like the breath of a sleeping titan. Using sonar backscatter imaging, scientists identified more than 300 gas seeps within a 20-kilometer radius of the swelling dome, an astonishing number. These seeps weren't randomly distributed. They formed crescent-shaped alignments, mirroring the thermal anomalies and the asymmetric uplift of the seafloor. Near many of these seeps, researchers discovered mud volcanoes, cone-shaped structures built by pressurized slurry erupting from deep underground. These features are more than curiosities. They are pressure valves, geological scars, and their emergence here, in such number and intensity, is deeply alarming. Chemical analysis of the gas plumes turned the concern into dread. Traces of helium-3, an isotope almost exclusively linked to Earth's mantle, were detected. These gases are not the byproduct of decaying marine life. They are the breath of something deeper, volcanic in nature, primordial in origin. Worse, gas ratios of CO2 to sulfur dioxide match those found in active subduction zone volcanoes, despite there being no subduction zone here. What could explain such volcanic fingerprints in the middle of a tectonically quiet basin? A buried seamount? A nascent hotspot? Or something else entirely? Mud samples retrieved by ROVs revealed strange mineral patterns, silica veins, pyrite crystals, and heat-altered clays usually found near active magma chambers. Some vent areas even emitted faint tremors, barely perceptible to human instruments, but disturbingly rhythmic. The Gulf isn't just leaking gas, it's breathing, and every plume, every eruption may be a signal. The pressure is rising, and the Earth is shifting from silence to speech. Why here? Why now? These are no longer scientific questions. They are warnings. Anomalous seismic activity, tremors beneath the tide. In early 2024, a curious uptick in microseismicity was recorded in the Gulf's deeper waters. Small tremors, none above magnitude 3, were recorded in clusters, concentrated near the swelling dome. Initially dismissed as tectonic background noise, these quakes have since drawn closer scrutiny. Some display harmonic tremor characteristics, a telltale vibration pattern associated with volcanic activity. Others are repeating quakes, similar to those seen in active geothermal zones, where magma or pressurized fluids push through fractures. Seismologists installed temporary ocean bottom seismometers in early 2025. What they found startled them. Deep beneath the Gulf's murky waters, the Earth is vibrating in pulses, low-frequency rumbles that echo like the rhythmic breath of a restless giant. This is no ordinary seismicity. It's something deeper, something more alive. A hidden volcano? The evidence mounts. All the signs seem to converge on one unsettling possibility. A large, concealed volcanic structure is awakening beneath the Gulf of Mexico. But here's the twist. It's never been mapped. Unlike the Pacific Ring of Fire or the Atlantic mid-ocean ridge, the Gulf has been seen as relatively volcanically inactive. No modern eruptions, no lava fields, no historic ash layers. But that may be a misreading of its deep history. New magnetic anomaly data, pulled from both surface vessels and deep-sea drones, shows patterns consistent with ancient volcanic flows. Flows buried beneath miles of sediment, buried but not dead. One hypothesis gaining traction is that an extinct seamount, essentially an underwater volcano, lies beneath the bulge. Once thought long dormant, it may now be reactivating due to shifting tectonic pressures or a new upwelling of magma. It could be part of an ancient rift zone, or worse, it could be something entirely new. Geochemical red flags, clues in the water. As gas seeps continue to rise, scientists have been testing their chemical composition. What they've found is deeply concerning. Elevated levels of CO2, sulfur dioxide, and even hydrogen sulfide are being vented through the ocean floor. These gases are often linked to volcanic systems, especially ones with active hydrothermal circulation. But it's the ratios that alarm researchers. The proportion of sulfur to carbon in these seeps mirrors those found in known volcanic arcs, and the helium isotopes point to a deep source, far below the sedimentary layers typically associated with oil or gas fields. In short, these aren't just organic decay products, they're volcanic gases. If the flux increases, it could destabilize the seafloor. In worst-case scenarios, rapid gas release could trigger underwater landslides, potentially even tsunamis. And that's not just a theory. The tsunami threat, unspoken risks. In 1998, a similar submarine landslide off Papua New Guinea unleashed a tsunami that killed over 2,000 people, despite no earthquake warning. It was triggered by rapid gas release and sediment collapse. Could the Gulf face a similar risk? If the rising dome continues to swell, or if gas pockets reach a critical pressure threshold, the seafloor could rupture. Entire sediment blocks could collapse, displacing billions of gallons of water in an instant. And unlike the Pacific or Atlantic, the Gulf of Mexico is almost entirely enclosed. Its waves would have nowhere to go but inland. From Galveston to Tampa, the implications are chilling. Gulf Coast vulnerability, a ticking clock? The Gulf Coast is home to over 17 million people. It hosts major cities, oil refineries, shipping lanes, and fragile coastal ecosystems. A submarine eruption or gas-induced landslide could disrupt not just local communities, but the entire national economy. Power plants, pipelines, and chemical facilities hug the coast like a necklace of risk. Even a minor geological event could cause cascading failures, floods, blackouts, and mass evacuations. And yet, few emergency plans exist for underwater eruptions. Why? Because no one expected one until now. Scientific urgency, the race to understand. The National Oceanic and Atmospheric Administration, NOAA, in partnership with several universities, has launched a rapid response study of the Gulf bulge. Autonomous underwater vehicles, AUVs, are being deployed to map the structure in 3D. Deep-sea drilling programs are being proposed to extract core samples, and real-time gas monitors are now stationed at key seeps. This isn't just academic curiosity, it's risk assessment. If the anomaly continues to grow, scientists may have only months or weeks to determine its nature and whether we're dealing with a reawakening volcanic system or something entirely unprecedented, because in geology, the only thing worse than a slow-building threat is one we don't understand. Is this the start of a new Gulf hotspot? There's another theory gaining quiet momentum. This isn't just a single volcano. It could be the beginning of a new volcanic hotspot. Hotspots, like the ones beneath Hawaii or Yellowstone, are fueled by deep plumes of mantle heat. If one is forming beneath the Gulf, it could reshape the region's geology for millennia. We might be witnessing the birth of a new volcanic chain. The earliest plume, the first dome. Think about that. What if, 1,000 years from now, the Gulf hosts its own volcanic islands, lava rising through the ocean, forming new land? It sounds fantastical, but geologists are no longer ruling it out, because all the signs are there. Uplift, heat, gases, tremors. This might not be the end of a geological mystery. It might be the beginning of a new chapter in Earth's violent, creative power. What comes next? In the coming months, scientists will launch a broad effort to understand what's rising beneath the Gulf. Advanced sonar and magnetic sensors will scan the seafloor to detect hidden structures. New underwater seismometers will monitor even the faintest tremors, early warnings of moving magma or crustal shifts. At the same time, deep sea drilling will extract samples from within the dome, seeking signs of heat, gas, or pressure buildup. Scientists are also modeling possible collapse scenarios, trying to predict what a sudden rupture might unleash. Landslides, shockwaves, even tsunamis. Emergency planners along the Gulf Coast are being alerted. Evacuation strategies may need to evolve quickly. But what if things accelerate? What if tremors cluster, gas surges, and the dome swells faster than expected? That's the silent danger of Earth's deep systems. They don't speak loudly. They whisper, shift, tremble, and then act without warning. The final question, are we ready? The Gulf of Mexico has never been thought of as a volcano zone, but maybe it is. Maybe we just never looked closely enough. Now, something ancient is rising from below. Something with heat, with motion, with intent. It may stay quiet, it may not. But the question is no longer if something is happening beneath the Gulf. It's what and how soon. We stand at the edge of a mystery, one that could rewrite our understanding of the American South, our coastlines, and the forces that shape this world. Stay alert, stay curious, and most of all, stay ready. Like this video if you want more updates on America's geological surprises. Subscribe to follow new discoveries from deep beneath our planet. And tell us in the comments, is this a sleeping volcano or something even stranger? Thanks for watching. And remember, the Earth never sleeps. It only waits.